In your younger days as a student, one of the things that you might have done was taken a pen like this and given it a rub on your shirt and taken a couple of little bits of paper and found that the paper was attracted to the pen and would lift the paper up. Alternatively, you may have gone into the library where there's carpet and scruffed your feet on the carpet and come along and touch somebody on the nose, your friend on the nose or the ear, and give them a little shock. Well, whatever your childhood experience with static electricity is, this is what we're looking at in today's video. It's static electricity that we're talking about. Electricity that doesn't move. Electricity that is stationary. So to begin our exploration of that, I've got here a polythene rod. And I'm going to give it a little bit of friction, a little bit of rubbing, creating a bit of friction in the same way as I did with the pen. And I will put that there and then get the cloth and put the surface of the cloth near the rod. And I hope you can see there that what's happening is that the rod is attracted to the cloth as a result of that rubbing. Now, again, if I take a cloth and the same sort of cloth and a same sort of rod and bring that close to this rod that I've got here already, you can see that this time I'm not getting attraction. What I'm getting is repulsion. I'm finding that this rod is repelling this other rod. So this is a feature of static electricity that we have as a result of putting those charges on the rod. We have the generation of forces. If I take the cellulose acetate rod, give that a rub, not too sure now which end, but this is it. Again, but this time we've got attraction. So, what's our explanation? Or, to begin with, what was the explanation of the early experimenters? Well, first of all, what they worked out was that in order to explain all that they could see happening with static electricity was that they only needed two different charges. One they called positive and the other one they called negative. Those two were sufficient to explain all of the things that they saw. One of the reasons why positive and negative was chosen instead of just say A and B was that one could balance out the other. And when they had equal amounts of each of those charges, we had a balance for charge. Or we could say that the body was neutral when it came to electricity. They also concluded the charges that were the same or like charges repelled each other. That is, they pushed each other apart from one another. And that unlike or opposite charges, positive and negative charges, attracted each other. Now, of course, we've got a much more sophisticated and better understanding of that. And that, of course, relates to the structure of the atom. What we now know is that we have here all of these non-metals, these non-conductors of electricity are made up of atoms, and in the centre of those atoms we have the nucleus. Inside that nucleus we have positive charges. Those positive charges are known as protons. Around the outside we have negative charges, and those negative charges are known as the electrons. We also have some neutrons at times in the nucleus. So our explanation now is that when this rubbing occurs, what happens is that the electrons are attracted more by one of these non-conductors than the other. So in this particular case, when the polythene rod becomes negatively charged, what we assume is happening is that in the process of rubbing, electrons are pulled from the cloth onto the rod. The atoms in the rod having a stronger attraction for electrons. In the case of the cellulose acetate rod, we find that the cloth has a stronger attraction for electrons, and the acetate rod will give those electrons across to the cloth. So this basically is our answer to why this happens. So when we give the pen a rub on the shirt, we put a charge on that. The charge is able to attract the cellulose that's in the paper, presumably the polar oxygen and hydrogen bonds that are there, and so that becomes attached to the pen. So these things have an explanation after all.